Hello everyone, welcome back to my YouTube channel. This is Lavanya SA from Sri Venkateshwara College of Engineering, Department of Electronics and Communication. Today I am going to do video on digital system design using Verilogs. And topic will be on Verilog behavior, Verilog code for 4:1 MUX. Our topic is 4:1 marks, and let us start from the introduction. Before moving to introduction, let us know what is MUX. MUX stands for multiplexer, a device that chooses between multiple input signal and send the selected signal to the signal output line. It is also named as a data selector. It selects one of the four inputs based on the values of the control signals. Understanding its implementation in Verilog is essential for digital signals. Here we have mentioned 4:1 MUX. 4:1 MUX have a four inputs D1, D2, D3, and it has a selected inputs to A and B, and it has a single output called it is labeled as a Y. Now our topic is basic functionality of 4:1 MUX. 4:1 multiplexer is used for generating the output carry of a full adder. A and B are the bits to be added, while C in is the input carry and the C out is the output carry. 4:1 MUX route one of four inputs to a signal output. The selection line are converted into a binary number that corresponded to the input that will appear at the output. For example, if no selection line is chosen, then the binary number is going to be as 0 and 0. The selection is controlled by two selected lines, typically labeled as a S0 and S1. Here we have shown S0, S1 and S2. Each connection of a selection line corresponding to one of the input line begin sends to the output. Our next topic is on Verilog. What is Verilog? We all know it is a hardware description language, but it is used for designing and behavior and structure of our electronic system. The purpose of its use is to design, simulate and verify the digital circuit system on a chips and more. It is an essential tool in electronics and semiconductor industry, which will be very useful for our future electronics students. It allows design to describe the behavior and structure of the digital circuits. Behavior model abstracts the hardware implementation focus on the design. Here the topic is on behavior modeling in Verilog. The purpose of feature of Verilog is can be described the behavior of the logic circuit at the gate level, including the delay for a switching each gate. It defined by a IEEE stance and is an entry format for a variety of EDA tools, including synthesis, simulate, and a formal verificational tools. The history of Verilog is not so necessary for the topic. Behavior modeling describes how a circuit behaves rather than how it is structured. It allows for a higher level abstractions that simplifies design and testing. Verilog provides structure like always, blocks and assign statements for this purpose. In the further topics, we will see some more examples where we use always, assign, blocks and etc. MUX Verilog code structure. The code structure include module definition, inputs, outputs, and internal logic. A MUX Verilog code structure typically includes a model definition with inputs ports for the data inputs to be selected, a selected signal to choose which inputs to forward, and an output port to carry the selected data. The module should include input ports for the data lines and selected lines. The output ports will be defined to reflect the selected inputs. This is a small example. Writing the Verilog code. As we all know, Verilog is the hardware description language which is used for model design and simulate digital circuits. Our digital components like multiplexer, flip-flop, or a processor function and interact are the describes how digital components works. Engineering we use Verilog to create a circuit design that can be synthesized into a physical hardware such as FPGAs AS or a ASICs. In short, Verilog is a programming, but instead of writing software, we are designing hardware logic. The code starts with a module declaration formed by input and output definition. The always block is used to implement the selection logic for the MUX. A case statement can be employed to determine the output based on the lines. Here is the example for Verilog code for 4:1 MUX. Here we have used, as we have said, module starting for the declaration we use module and data. Here we have written input via 3:0. The data in is 4 input datas. We have given 4 data lines and we have given that input wire as a 1:0, that is 2 bits selected. And for the output we have written cell that is the cell is stands for signal, and output, and for output we have written output register out. According to the truth table we have written the code and need to execute. Testing the 4:1 MUX. Testing is the process of evaluating a system component or a product to ensure it functions as expected. It is very crucial for verifying the functionality of a MUX design. The In the context of a software, hardware, or a digital system, testing involves identifying the fixing defects, verify the requirements, and ensure reliability. Testing benches can be created to apply different inputs, combination, and select lines. The expected output can be compared against the actual output to ensure the correctness. Here, these are the key aspects of the testings. Purpose of testings are validation, verification, reliability to confirm that system needs user needs, and verification to ensure the design or a course behaves as intended. Reliability, identifying and address defects to enhance stability and performance. There are different types of function testing. One is functional testing, non-functional testing, white box testing, black box testing, hardware testing, etc. These are the few types of functioning text. Common application of 4:1 MUX. 4:1 MUX are widely used in data routing and switching application. They are essential in digital circuit for selecting data path based on a control signal. Multiplexer can be also used in memory management and signal processing. The conclusion for the multiplex 4:1 Verilog code is writing behavior Verilog code for a 4:1 MUX simplify the design process and to understand the structure of electronic device. Understanding the selection logic is key to efficient digital design. Mastering MUX implementation in Verilog lays the groundwork for more complex designs. For the further reference, the author written by Samir Palintkar, A Guide to Digital Design and Synthesis, and the second author I refers to Michael D. C. Ilentai, A Digital Design with Verilog HDL. These are the two reference books which I suggest you guys to for a further information. I hope this video was enough with the sufficient information. For the further information, as I have referred the two books, go through it and collect the information, the necessary things, and I I request you all guys to please like and subscribe and share with your friends, which helps my academy a lot. I request once again, please share and like the video and share with your friends, which helps my academic. Thank you all. See you in the next video.